This represents how most people experience generative AI. A prompt goes into a single language model, returning text. But zooming out, the true scope of an agentic system becomes visible. The LLM is only a fraction of the total architecture. Designing a production-grade agentic AI requires the same rigor as building any other large-scale software system. When a single prompt is tasked with complex reasoning, real-world complexity and latency cause the system to break down. But scaffolding a model with rigid, deterministic software constraints provides the critical safety, reliability, and utility required for real-world production environments. We need to build a reliable agent architecture from first principles, moving beyond prompt engineering to systems design, layer by layer. This means treating the foundation model as an unreliable, probabilistic upstream dependency that requires heavy structural support. The first layer is a model router block. Lalling minor steps through massive reasoning models creates latency and cost bottlenecks. The router directs simple tasks to fast, cheap models, reserving frontier models for complex synthesis. Regardless of the model used, any output intended for a downstream backend system must be formatted predictably. Communicating with internal databases through free-form conversational prose is a failure state. Instead, the model must return data strictly as JSON schemas, allowing your software to extract exact values for dates, times, and names. Enforcing this strict data structure at the very first model layer acts as your primary impenetrable defense against massive cascading application errors. Next, we add the external tools layer. To interact safely, a model needs a rigid schematic barrier. A vague instruction like update user is rejected, while a structured block with specific programmatic parameters successfully passes through. We also have to differentiate between the risks of read tools, like checking a calendar, and write tools, like processing a refund. High-risk actions require strict timeout limits, predefined retry rules, and human-in-the-loop approval gates. Treating all external tools as strict, schema-enforced APIs prevents hallucinated logic from altering real-world data. A major architectural flaw is the assumption that every piece of context should be stored in a single vector database. Production systems must decouple state from memory. The state database holds immediate workflow context in a low-latency store. The separate memory store contains semantic history. By pulling a single ID from state and one paragraph from memory, the system builds a targeted payload. Stuffing an entire memory archive into the model's prompt window causes severe context bloat, which drastically degrades reasoning and increases latency. Separating fast state from deep memory ensures the model only sees the minimum context necessary to make its next decision. The orchestration layer is the explicit control flow that wraps around the entire system. Reliable agentic workflows rely on these defined, application-level control loops to navigate complex edge cases. There is a strict line between a model's probabilistic suggestion and the application code's deterministic validation. When a model proposes a cancellation, hard-coded logic must step in to verify user ownership and policy rules before the API is called. The application code, not the LLM, remains the absolute source of truth for all business rules. Traditional software evaluation relies on checking if a function runs without an exception, but agentic systems require a deeper layer of scrutiny. A model can return a perfectly formatted, technically valid response that actually contains a completely hallucinated, disastrous decision underneath the surface. We use trace-level evaluation. Every agent step is logged as a discrete span. Intent, retrieval, and tool arguments must be scored separately. Here, a red warning on retrieval reveals a hidden failure, even if the final text looks polished. Evaluating the full trace is the only way to prevent systemic failures from being masked by a clean final response. Within the fully assembled architecture, a user request enters the orchestrator, queries the separate databases, formats its JSON payload, clears the validation gate, and triggers the API. The orchestrator manages this deterministic flow, while telemetry logs a completed trace for evaluation. Architectural complexity is the cost of building reliable systems with unpredictable foundation models. Scaling an agentic system is an exercise in back-end system design and data architecture. Reliability comes from structural decomposition and strict API contracts. Engineering these systems with architectural rigor provides the stability needed for real-world deployment. The potential of agentic AI is realized when we treat it as a rigorous software engineering discipline.